It's me again. I'm back with another short video on deep learning. This time we're going to look at noise to void deep learning, which is a very simple deep learning denoiser method. So before I get started with that, I just want to show you at the end of the last video, at some point near the end, we had a problem with the 3D view, which was not visible. The reason for that was that because of the intensity calibration, the scale was way off the chart. So when you have anything lost like that, you can come to window leveling on when the 3D window is there and click on reset. So there we have again the original presets, and you can calibrate, or you can do a quick contrasting. You can do that in different ways to make nice visualization. That's actually a very nice visualization. Okay, so now we go to new session, clear without saving. And now we're going to do noise to void denoising on some powder data, which is an example which works quite nicely. It's got a lot of speckle noise, and you've got this data available to repeat these steps yourself. So we're going to import objects. There's metal powders, which are also from additive manufacturing. This is a small cropped volume. So just to make this data easier to handle, only 400 pixels cubed. And this is what the data looks like. Obviously, it needs denoising because to make any analysis on this, any segmentation will be difficult, and then therefore the analysis won't be very good because of the difficulty in segmenting properly. So what we do here is noise to void works very much like training as a deep learning segmentation model, except that you need to give it a mask, and that's all. Like in this case, we can make the mask with a region of interest. Let's call it mask. I've created an ROI on the segment new ROI basic tool. So it's an empty ROI at the moment. And then we take this full slice, single slice brush, and we take this particular slice, and let's see for in the data where another slice, and let's take a third slice, covering sort of the different types of images in the data, so you can go near the end. So you can scroll through the data like that. Now we have 3 slices. So if you look carefully, I don't know if it's in zoom visible, there's some horizontal red lines that are visible in the other view. So we have 3 slices. If we click on the image and we go to artificial intelligence, filter with AI, is it? No, this one, sorry, the last one. Custom deep model architectures, noise to void. So here we want to create a new one. Let's see. There we go to train, and we select new. So we're going to call this the training, or no, this is a demo noise to void 14 March, and select OK. Now it's not trained, so we need to go to training, and sometimes everything's not visible at the bottom here. Whoops, now I've lost Dragonfly. Let's just make it bigger. Okay, there it is. So we, as input, we take the image, metal powders. We select the mask ROI, and if you don't have a mask, it would take all images as the full mask, which just would make the training a lot longer. In this case, I don't want to take too much time, so I'm going to make only augmentation 10, but you can increase augmentation. If you would like a stronger model, it just takes longer. The more augmentation you make, the longer the training takes. And I'm not going to go into more details here. There's also a visual feedback frame, which we didn't select any in this data. Let's do that. So we can do that while it's setting up like that. So we go to main, annotate, and select a little rectangle like that. And now we can go to visual feedback and select that region 10, and we click on train. So that's all that is needed, and it's giving you all the parameters of the denoising model, which on the right you see the progression of this model. The inference is, if you maximize it, this is what the model looks like at this point. If you minimize it, that's what the original data looked like. So you can toggle between what the original data looks like and what the model at the moment looks like. And you can see that there's definitely an improvement happening there. You can also see the improvement as these values drop here. And as I understand this, the loss value is the reduction in the smaller the loss value is, the closer the model predicts compared to what the ground truth data is. In this case, there's no ground truth data, so it uses a different algorithm, but in general, the deep learning works like this. And then val loss uses the same comparison compared to the validation data. So it's not really relevant here, but it actually found a solution in quite a short time, and it stopped because of the early stopping parameter, and it thinks this is a good result. So I'm going to close there. If you would like to do more training than just a short training, you can increase augmentation, and you can also access the parameters, right click, and no, not in that way. Let me just see, where is that? That's the statistics. So you could add more slices into the mask to give it more data to work on. You could also increase augmentation. You could also increase some of these values here. And I'm trying to see where the training parameters are. So you could also here at this point change the epochs number to 100, but there's also early stopping, which is not set here. So if you would like more frames, you could reduce the patch size from 64 to 32. It would make more patches in total. So if we do that, it should continue longer. But actually, if you I'm not sure how to reduce early stopping at the moment here. I will add a note about that later. Basically, increasing augmentation and increasing the number of slices in the mask just will make slower training per epoch, and then you will get a better result in the same number of epochs. So we're continuing the training, so it doesn't seem to make much improvement at the moment. And it could be that a smaller patch size is not really a good idea here. But the main point is just I wanted to show you where to access noise to void. And you can also read in the help file the information about the noise to void algorithm, which was based on a publication, which you can also access from there. So with all deep learning models, the more data you provide in, the better it becomes. This is a small test data for training. So if you provide real big data, it will take longer and it won't do early stopping, most likely. Okay, that's all for this video. I think I'm going to stop it there. And just to close that, let's just say we want to save the changes, yes. And let's just show how I would like to apply this model. It's under the main panel, and we go to, what did I call it? There's a noise to void. There's many noise to void models here. Demo noise to void 14 March. This is the one we just did. So we can preview that on the current slice. And that's what that looks like. Slight improvement, and you can test that out yourself further. So, okay, that's all for this video. Thanks.